Okay, so in this video, this is a continuation of the last video talking about solving linear systems using graphing. It's not always going to be so convenient to use graphing, although I will say, a calculator can go a lot faster than us, but nonetheless, we have to know how to do these algebraically by hand for a number of reasons, right? So we're going to start with the very basic. So the first way to solve these algebraically would be to use what's called substitution, and it's a very intuitive way. And remember, we're talking about 2 by 3, right? These are the baby ones. But anyway, substitution is a very intuitive way of solving these algebraically, right? So if you remember from the video we had about graphing, we're looking for points of x and y where these two equations agree with one another. In other words, what values of x and y together in coordinate pairs uh, satisfy both, right? Now, this is a lot more straightforward than it sounds, right? So it's called substitution. So always take the path of least resistance when you've got these. So here we're being told that x is equal to 25 minus 3 times whatever y is, right? And we can actually take this and say that this is actually literally x. I can plug it in here for this exact same x in the other equation, right? So instead of saying 4x plus 5y equals 9, I can actually say 4x plus 5y equals 9. This being x, right? So from here, instead of having an equation that has two different variables, right? Now I have just one variable, just y. So I can actually solve for this. So I'm going to simplify by distributing 100 minus 12y plus 5y equals 9. Combine like terms, negative 7y equals 9, 100, just like that. Subtract 100 from either side. So now I have negative 7y is equal to negative 91. And then divide by negative 7 on both sides. That gives me y is equal to positive 13. Let me do that in my head real quick. 70, 21, yes. Okay, so I know y is equal to 13, right? Now I can substitute again. And you're probably wondering, well, substitute how, you fool? Well, I know y is 13. I don't have to say it's an unknown variable y anymore. I can take that y and plug it in here or here if I want. I think I'm just going to plug it in here because x is already by itself on this one. So I'm going to do that. So now I've got x is equal to 25 minus 3 times y, right? That's this guy right here. And now I just need to do some quick maths, and I'm going to have what x is in fact equal to. So x is equal to 25 minus 39, right? And then I go ahead and subtract. So 25 minus 30, that would be negative 5. Sorry, my phone was ringing. That would be negative 5 minus another 9, negative 14. Okay, and there you have it. So all I need now is to just prove my point to you so you don't think I'm just rambling nonsense and think I'm crazy. So when I plug into this equation for the x and y that I've got, I should get 9. So 4 times x, negative 14, plus 5 times y, positive 13, is equal to 9. All right, well, let's pull up our handy-dandy calculator to make sure I don't screw this up. Okay, so 4 times negative 14, right, plus 5 times 13, and holy dog crap, there it is, I get 9. Okay, so I know this works. And this is actually really intuitive. Most kids, when they forget how to use other methods that we'll learn later in later videos, of how to solve systems, they usually will revert back to this just intuitively, because it makes sense. Now, when systems start getting a lot more complicated than this, well, you may not want to use substitution. Okay, take two on this one. So for this second system here, we're going to use something similar. Now, it's not so obvious here how I'm going to go about solving this. What I would like to do, or what I would like to have happen, is that I just have one of the variables by itself so that I know what it's equal to, even if it is in terms of the other one. But I don't really have that here. I could divide by 2, divide by 2, divide by 2 here to get this y by itself, right? But then I'm going to be stuck with an ugly fraction here, and we want to avoid that always. Here, however, if I just do one simple step, namely minus 2y to both sides, well, now x is by itself. I have x equals 14 minus 2 times y, right? Simple enough. So now I know what x is relative to y, and I can take x and plug it in here. So I can say 2y is equal to x minus 10, right? And I've got some unnecessary parentheses, so I'm just going to rewrite without them. So 2y is equal to 14 minus 2y minus 10. I say they're unnecessary because nothing's being distributed into them. But anyway, so I'm going to go ahead and combine like terms. 14 minus 10, that gives me a 4. Add 2y to both sides, and we get that y is equal to 1. So I'm going to write that off to the side over here. Okay, so now that we have that out of the way, now it's as simple as just plugging in like how we did before. So I'm going to plug in y equals 1 to this guy here. So 2 times y should be equal to unknown x minus 10. And we're going to get that x is equal to 12, right? So, okay, I skipped a lot of steps. 2 times 1 is 2. Add 10, right? And that's where we get x is equal to 12. Okay, so if I was so inclined, right, I could easily just go ahead and plug in and just make sure that I get the right answer. So let's go ahead and do that. Just that way you don't think I'm insane, right? So I'm going to use this top one. So x plus 2 times y should be equal to 14. And, well, 2 times 1 is 2. 12 plus 2 is, in fact, equal to 14. Okay, so we have got it. Okay, so I don't think I need to do another example just because this video has already run a little bit long. But if you do need any more help on solving 2x3s with substitution, obviously you know where to find me. Shoot me an email. You know how it goes. Goodbye.